Bismillahirrahmanirrahim. This is the second video on maximum power transfer, and in this video we'll be primarily solving two problems involving dependent source. So let's see the first problem, practice problem 4.13, and this is the circuit, and as you know this is dependent source. The diamond sign is for dependent source, and it is a voltage source. It is depending on this voltage Vx, and here also we need to find the RL, the load resistance for maximum power transfer, and also we need to find the value of maximum power as we did in the previous video. So the first step is to separate the load. So we have separated this, and then at this terminal we'll find VThevenin voltage, and so we redraw it with VThevenin written here, and we assume a current I in the first loop. Now note, in this loop there is no current flowing because the circuit is not complete, so the current in this loop will be 0, and so the voltage across 4 ohm will also be 0. Now if you write KVL equation, and I start from one corner, so I start from here, so minus sign, minus 9 plus 2i plus 1i and plus 3Vx is equal to 0. Now how much is Vx? You can see from here it is 2 into this current I. So for Vx we will write 2 into I. Vx is 2 into I. So from this, and from here we can calculate I to be 1 ampere. And now we need to find VThevenin. So we'll take this loop. We write KVL in this loop. So we're starting again from bottom, so minus 3Vx plus 1 into I. Since there is no second current, no I2, so we'll only I. And this one is 0 voltage here, so 0 volt plus VThevenin equals 0. And now we're plugging in, for Vx we plug in 2I, and for I we plug in 1. So solving, we find VThevenin to be 7 volt. So VThevenin we have found out. Now we need to find RThevenin. Now for finding RThevenin for circuit having dependent source, we have a different technique, and that is, you must have learned in the Thevenin's theorem, but I'll repeat. And that technique is that we either connect a current source of 1 ampere here, or we connect a voltage source of 1 volt, or we short circuit. So I'll connect a voltage source. I'm connecting a 1 volt voltage source in this circuit. I have also marked the currents. So this is I1, this is I2, and this is I0. And to find RThevenin, all we need is to find I0. If you find this current I0, then volt divided by current will be the resistance. So 1 volt, this 1 volt divided by I0 will give RThevenin. So our aim is to find I0. So let's take help of nodal analysis. This node voltage here we calling it V1. So I1 entering, I0 entering, and I2 leaving. So I1 entering, I1 plus I0 is equal to I2 leaving. And now we convert this in terms of voltage. I1 will be 0 minus V1 divided by 2. So 0 minus V1 divided by 2. This circuit here will be 0 minus V1, and this is also adding in the same direction, so plus 1. So 0 minus V1 and plus 1 volt divided by 4. Now this is important that you understand that this source is adding. If it is adding, you add. If it is subtracting, you subtract. Since the current due to this source will also go up, which is the direction of I0, therefore we are putting a plus sign. And this one now is V1 minus 0, and again we have a source. Now this source direction is upwards, whereas our current I2 is downwards. Therefore now we'll use a minus sign for 3Vx. So we are using a minus sign for 3Vx divided by 1 ohm resistance. And now if you look at this circuit, so Vx is actually 0 minus V1. So 0 minus V1 is Vx, therefore Vx is minus V1. So we plug in here, Vx is equal to minus V1, this one, and then we solve. So we find V1 is 1 over 19 volt. So we have found this voltage V1. We need to find this current I0, and from here you can see this was the equation for I0. So we'll use this equation, and let's see, I0 is 0 minus V1 plus 1 divided by 4. Now we plug this value of V1 in this. So plugging in, we get I0 is 18 over 76 ampere. And now we'll use this formula to find R Thevenin. So R Thevenin is 1 volt divided by I0, 1 divided by 18 over 76. So 76 over 18, that means 4.22 ohm. Okay, so the first part was to how to find the value of RL for maximum transfer. We know that for maximum power transfer, RL is equal to R Thevenin. So RL will also be 4.22 ohm. And the second part was to find the power, and this is the formula for maximum power. V Thevenin is square for RL. So V Thevenin is 7, so square 4 multiplied by 4.22. So our answer is 2.9 watt. So we'll do another example just to emphasize the concept. This is from end chapter, problem 4.70. This is the circuit with a dependent source here. So we'll follow the same technique. Separate the load resistance. Here the voltage will be V Thevenin. So we'll find this voltage. A couple of points to note. Since the current flow through 6 ohm resistor is 0. Now look, if in this circuit there is no current flow because this circuit is not complete. So the current in this will be 0. That means Vx will also be 0. And if this Vx is 0, then this 3Vx will also be 0. And 3Vx is 0, then therefore the voltage drop in 5 ohm will also be 0. So now let's proceed. 3Vx is 0. V5 is 0. So now this voltage is 0. This voltage is 0. Therefore V Thevenin will be actually equal to V15. So V Thevenin is equal to V15. And V15 we can find from this circuit by voltage division, 4 volt divided by these two multiplied by 15. So by voltage division we get V Thevenin to be 3 volt. Now we need to find R Thevenin. Okay, so this is the circuit. Now for R Thevenin, as you know, that we have to make the independent source 0, and we have to connect a voltage source or current source. So in the previous example we connected a voltage source. Now I'll connect a current source so you have idea of both. So I've connected a 1 ampere current source, and this voltage source is removed, short-circuited. And since we have connected a current source, we need to find now V0, because R Thevenin will be V0 over 1 ampere. So our Thevenin will be V0 over 1 ampere. So we've redrawn the circuit with some of the currents now marked. This current we are calling I1, this is I2, I3, I4. First of all, Vx. Now this current is 1 ampere, and you can see this same current is flowing through here. So this will also be a 1 ampere in this branch. So 6 multiplied by 1 ampere will give Vx. So Vx is 6 volt. And now we write the nodal equation. At node 1, you can see this current I1 entering, I2 leaving, I3 leaving, and I4 leaving. So I1 is equal to I2 plus I3 plus I4. And now converting these in terms of a voltage, I1 is 0 minus V1 divided by 5. So 0 minus V1 divided by 5. This one is V1 divided by 15. Actually V1 minus 0 divided by 15. But there is no need to write 0. This one is V1 minus V0 divided by 5. V1 minus V0 divided by 5. And this one is 3Vx. So now we write the value of Vx here. Okay, second node, also we write the equation. I3 entering, I4 entering, and 1 ampere entering. So I3 plus I4 plus 1 equal to 0. And this also we convert into voltage. This one is V1 minus V0 over 5. V1 minus V0 over 5. I4 is 3Vx plus 1. Now converting in voltages, or simplifying this now. For Vx we replace 3, and then simplifying we get this equation, which we'll call equation number 1. Same here, replacing Vx by 6 and simplifying, this is our second equation. Now let's solve these two equations. We have these two equations and we need to solve. So from here we write V1 is V0 minus 95, and we plug in the first one. So putting in equation 1 and then solving. V0 is 98.75. So we have found V0. Now we can find R Thevenin by this formula, V0 over 1 ampere. That means it is 98.7 ohm. And now the power, maximum power, using this formula, V Thevenin was 3 square 9 divided by 4 into R Thevenin. So it is 22.78 milliwatt. So I hope this gives you an understanding as to how you can solve the maximum power problems with dependent source. Thank you.